Welcome back, my friends. We're going to today talk about how to take apart a problem that has three equations with three variables. And so let's begin. Well, we see here, we're starting with number one here. It's always good to take a look at the problem first before you just dive in and start doing stuff. Remember that one of our goals, in order to make this problem more simple, is to eliminate some variables. So I kind of like to think about what would happen if I add some of these equations together. My first tip is don't add all three together unless it magically gets rid of two of the variables and leaving you with one. Instead, I'm just going to try to add two equations together. And if I add these two, that's not really going to do much for me. It'll get rid of the 18, but not much more. If I add these two together, hey, now we're talking. Look at this. That is quite a gift. Look what happens if we add these two equations together. The x's go away. This becomes 0. And then these y's here, 4y minus 4y, that's also 0. That also goes away. You don't have to write the 0 plus. I just want to show you that I did something. And then minus 2z plus z is negative z. Let's make a little line there so people don't think it's a 2. And then negative 18 plus 17 is negative 1. Hey, that means that z equals 1 because negative z equals negative 1, so therefore z equals 1. That is one of the three variables that I've now solved. And I can use that information to make this problem easier. I'm going to replace all of the z's with 1s. So for example, this plus z here is 1 now, because that's what it is. This minus z here is just minus 1, because that's what it is. And this minus 2z, this z here just goes away, leaving us with minus 2. I think I prefer to just write it like this. And so that's just going to be minus 2. And yeah, now we have two variables. And as we discussed off camera just right before this, when you're working with systems of equations with two variables, you can use elimination or substitution in order to figure out one of the variables. And we certainly could do that. So once again, look at the equations and see if you can add them together and eliminate something. You're not going to do this one here again because it'll just go to 0. I need an x or a y to be left over. So let's see what else we can do. I don't really want to add these two together because it also would not eliminate a variable. And I would like to eliminate a variable if possible. However, if I add, for example, this one and this one, that'll get rid of the x's and leaving me with some y's. So why don't we do that? So let's write this. 4x, I'm just going to copy it over here just so I can have it. It's a little easier to look at. A little easier to follow my steps. And so this equals 18. I'm just copying over that first equation and the last equation as well. Minus 4x minus 4y plus 1 equals 17. And let's add these two together and see what happens. If I add these two together, I get 0 minus 7y, and the 1's go away, equals 35. Divide both sides by 7, and I get negative y is 5. And so therefore y equals negative 5. Yeah, that's what I was afraid of. Yeah, I'm just going to write that over here to keep it with the z. So now I know that y equals negative 5. Now I have two of the variables figured out. And the third one is actually quite easy because once you have two, you just plug in what you know and then you're done. So what I mean, for example, is that this y right here is just negative 5. Can I do this? Can I fit this? You know what? I could if I didn't make it, if I made it a little bit skinnier, I think. Okay. And so what we get here is 4x plus 15 minus 1 is 18. I'm just going to call that equals 19. Subtract 15 on both sides, and I get 4x is 4. And therefore, x equals 1. And that means I have solved for all three variables. Hooray! Now, I hope you think that was easy, because I think it is pretty easy. The thing that made it really easy was that getting rid of two variables by adding those bottom two equations together. That was a stroke of luck. That's not always going to happen. And so we need to talk about how to handle problems where that doesn't necessarily happen so nice and smoothly. But if it does, certainly you want to take advantage of it, so you got to be on the lookout. Let's go ahead and look at number 2. If you're watching online, just pause the video here, please, and try to work it out yourself, and then wait for the explanation. And we're back. Number 2. Let's see here. Again, take a second to look at it a little bit. So I'm noticing a couple things here. I see that this one and this one both have a plus c, and this bottom one here has a minus c. So I think I'm going to pair them together to get two equations with two variables. Unfortunately, I can't just add these up and get two variables to go away. There are other things that you could do, but it's, I'm thinking like I can multiply this bottom one by 2, and then the y's would go away if I add it to the first one. But, I don't like to have to manipulate an equation if I don't have to. So what I'm going to do is I'm just going to do what I set out to do. So I'm going to take that first one, and I'm going to add it to this bottom one here. So basically these two right here. Now let's see if we can fit all this in on one page. Yeah, let's do it over here. 4x plus 4y plus z equals 4. And then we have 2x minus 2y minus z equals 12. And we're going to add all that together. I'm going to use a different color because these blues are melting together here. And that's going to give me 6x plus 2y equals 16. The z's went to 0. And I can actually divide both sides by 2 here, and I will. And that's going to give me 3x plus y is 8. And that's what I got from adding these two equations together. Okay, now I'm going to do what I said, but I'm going to use the second and third equations. And I'm going to put that, yeah, I'll just do it right here. We'll save that magenta pinkish stuff for later. So I'm just going to write this out. 3x minus 3x plus 3y plus z. And remember, again, the reason why I'm doing it this way is because I see that the z's will add up to 0. And that's why I'm putting these two equations together. 2x, minus 2y minus z equals 12. And then we're just going to add these two together. And we're going to get, use a different color again, x plus y equals negative 8. And now I have those two equations. Hey, And I can even put this one down here. Well, actually not so fast. Well, okay, but let's look at it. Let's look at it. Unfortunately, if we take these two together, we do not eliminate a variable. So we don't actually want to add these two together, at least not in the way they currently are. We could change it. We could multiply one of them by -1, and then if we add them, the y's will go away. Or we could, did I make a mistake? I did. Nobody caught it. You're supposed to catch it. That's -x. Minus 3x plus 2x is -x. Wow. Okay. Come on, guys. Minus x plus y is negative. So I could multiply by -1 and then the y's would go away. Or I could multiply the red one by 3 and then the x's will go away if I add them up. Now, I've learned in the last 20 years that multiplying by a whole positive number is for most people a lot easier than multiplying by negatives, because for some reason, whenever you do stuff with negatives, errors, it just attracts errors like a magnet. They all just come out of your brain and make errors everywhere. So for that reason, I'm going to take the red one. I'm going to actually multiply it by 3. I'm going to put this back up here. No, not this one. There you go. Put this one back where I had it. And I'm going to take that red one. I'm going to multiply it by 3. Okay, so I'm going to get minus 3x plus 3y. You know what? That's not where it was. The pink one is the one I had up there. This one was the result of that calculation. So for historical purposes, I'll keep that there. And so instead, I'll draw it right here. So minus 3x plus 3y equals -24. And now I'm going to take these two here, and I'm going to add these two together and see what I get. I'm going to get 0 plus 4y equals -16. Divide both sides by 4, and I get y equals -4, which is great, because that means I have one of the 3 answers. And actually, I'm almost done. Believe it or not, I have done most of the hard work now. Because once you have 1, it's really easy to find x. If y is -4, you can take one like this here, for example, and just put -4, add 4 to both sides, and you get 3x is 12. And you can say, oh, x is 4. And once you have both x and y, you know, you just plug it into one of these originals here, like, oh, this is 4, you know, and this is -4. And you'd get -12 plus z is -20. And then we add 24 to both sides, and we go, hey, z is 4. Okay, so can you see that once we have one variable solved, we're actually pretty much done. It's just a matter of plugging stuff back in and finding the other one. So I could keep going here, but I think that's good enough for now. Feel free to try some more problems. And please like, share, and subscribe. Buy my merch. Thank you very much. Have a good day.